Okay? So what I'd like to do today, and this is going to help again, give you some background for at least for the practicum exam. You know, what is this whole thing about selectivity? Okay? And what we're trying to figure out is obviously we're trying to control the weeds, but we need to protect our crops. I mean, that's essential. And so, you know, when you're spraying, what is it? How is it that you know, you spray 2,4-D or dicamba, and the broadleaf weeds are, you know, basically knocked back, suppressed, killed, and the grasses aren't in general, okay? And so I want to take you through what are some ways that plants are capable of tolerating certain herbicides. What are the main mechanisms involved, okay? So when we talk about selectivity, okay, think about this as, you know, in very simple terms, you know, the killing of some plants with doses of herbicides that have little or no effect on other plants. Remember, I've been repeating this I don't know how many times. You up your dose, increase your dose to high enough rates, pretty well everything will be killed. Selectivity is lost. You don't apply enough herbicide either because of miscalculation of application rates or nozzles, as we saw in IPM yesterday, nozzles being, you know, not being, you know, having issues or being blocked and so forth, and you won't kill anything, okay? So selectivity really involves where you're using the recommended rates for a product and you're allowing some plants to survive and others to be killed. Very simple terms, and here you see a graminicide. This is post-Cetoxidem, okay? And you see the grasses, the mushy, as we talked about, the breaking down of the plants right at ground level, okay? And this is clomazone, command, where the corn is gone and the bean and the soybeans are in place, okay? So, I mean, it's that. So how do they do it? I mean, what is it about them, about some of these plants to be able to do it? So before I do so, let me just take you through what can happen when you apply a herbicide foliarly. Since a lot of the herbicides are applied, more and more now are applied to leaves, I'll focus in on foliage rather than soil-applied herbicides, just to give you a sense. There's a couple of things that can happen, okay? And this is not what you want. You don't want to apply a herbicide and then have it being washed off by rainfall, okay? And deposited on soil, okay? That is not good for a product like, say, paraquat or glyphosate, okay, Roundup, that has no soil activity, okay? So, because once they hit the soil, they're typically going to be degraded. And that's not a bad thing. You want these products to be degraded, but you also want them to work. These are not soil-applied herbicides, but from a safety, environmental perspective, it's actually good that there is microbial, okay, decomposition or even photodegradation. You certainly don't want leaching, okay? If a product doesn't break down in soil and ends up in the water table, often the EPA would not approve this kind of herbicide, okay? So you want degradation, but you also want, you know, ideally you wanted it to stay on leaf surface. Remember we talked about wetting agents, adjuvants, okay? So we don't want this, generally speaking, okay? Now, you definitely want the herbicide to remain on the leaf surface, but you have to be careful, okay, that they might be prone, particularly if applied at high temperatures, high humidity, things like Banvel, dicamba, okay, you might get volatilization or photodegradation, okay? And so, you know, for these foliar-applied herbicides, you might say, well, how else then, if this is going to be an issue, what can you do? Well, one of the things for certain of the herbicides, particularly some of the phenoxies, okay, the 2,4-D, NCPA, dicamba, that are prone to be volatile, is that you basically don't apply them when the environmental conditions are not right. I.e., if it's 95 degrees and 80% humidity, that's not a good time to apply these products. They can easily move from a liquid phase to a gaseous phase and cause injury to non-target plants. Okay? So that's what can happen. This is what you want. Okay? This is what we're all aiming for. You want the herbicide that's applied foliarly, that has foliar activity, to be able to penetrate the cuticle and enter the plant. This is whether this is a contact herbicide, like paraquat, okay, or blazer, okay. You want it to enter and then hopefully go to the site of action where it's going to do the damage. So just wanted to take you through. I think all of us can kind of think about this, okay? So now what happens once the herbicide, let's say the herbicide, you've picked the right adjuvants, you know, if you had to put a sticker or a wetting agent, okay, to reduce the water tension on the leaf surface, okay? Let's say it makes it into a plant. What can happen, okay? There's some things that happen here that may not be a good thing. And plants, remember, plants are going to try to defend themselves. They're not just going to hopefully, you know, or allow everything to come in. A lot of plants, or some of them, will conjugate your herbicide to, within the plant, to things like sugars, amino acids, proteins, okay, that are already in the plant. They're natural plant constituents. The plant in some way, and I'm putting this in human terms here, recognizes that this is a foreign compound of some sort and say, you know, we're going to bind it to something that's not going to cause me damage, okay? And they basically then will render that compound immobile, okay, or inactive. A good example is linuron. Linuron does this, I mean, a good example are carrots. The fact that we could use linuron in carrots, and remember, linuron was that herbicide that ragweed, you know, that video I showed you about those growers that were spraying, you know, illegal herbicides in carrots just to see the color of the ragweed show clear so that they could hand weed the ragweed in a carrot crop. Well, that's part of the, you know, that was part of the problem in ragweed. But generally, the reason we could use linuron in carrots is that carrots basically took the linuron and basically bound it or conjugated it to sugars, and then the plant basically moved it to a vacuole where it did not damage it, okay? It didn't damage the plant. And eventually it was degraded, okay, to non-toxic compounds. Susceptible species can't do that. They can't conjugate for whatever reason, okay? Generally speaking, some physiological reason. Yes, Megan?
How long does it take for those compounds to degrade within inside the carrot or the plant structure?
It'll really vary. Often it has to do with how fast the plant is growing, the more actively growing it is. And so that's a good point. You know, is it a question of days? It might be days. That's where you have to be careful. If you use too much of the product, let's say you overdose, you know, you're saying, oh, I really want to hammer, you know, the ragweed and stuff, and you overdose. You know, you go 2x, 1x of over-recommended rate. First of all, it's illegal. Second of all, what do you think is going to happen to the tolerance of carrots? Carrots are taking this, conjugating it. The more you're putting in there, it's not going to be able to be fast enough. The rate-determining step of conjugation is not fast enough. There might not be enough compounds to conjugate. You know, you're going to get the linuron going in and really doing damage to the photosynthetic system, even in a carrot that's, because these crops are tolerant. Okay, they're not totally resistant. That's why I said you up the dose, you're going to run into trouble. Okay, but generally speaking, you stick with the recommended rates. That's why linuron can be used in carrots, but it hammers a lot of broadleaf weeds and some annual grasses. Okay. Now, you could have the compound. So here it's conjugated. As soon as it gets in, it's conjugated. It gets in, and it's put to the side. It's rendered inactive, okay, which is good from a crop perspective. You don't want the weeds to do that, obviously, okay? But often you'll have the compound moving to the site of action. So let's say you glyphosate, okay, and will cause a toxic reaction. It's going to get to where you want it to go, okay? And eventually, it will be degraded to inactive metabolites. Now, you want it to do the damage, okay? So if it's a photosynthetic inhibitor, you want it to go there and do damage, affect photosynthesis, okay? But you don't want then the herbicide to just be hanging around there, okay? You do have to show, and the EPA wants to see this in toxicology studies, that the product is degraded to inactive or safe, you know, byproducts, okay? So if this is, you know, any compound that's still active, is not broken down microbially, or will be not, the companies won't even further, you know, working on them because there's going to be issues with degradation and so forth. So, and the EPA is very strict about, you know, what are the byproducts, what happens, okay? So you definitely want to show this. Very early on in the discovery phase of a herbicide, okay, if the molecule is not degraded to safe products, the herbicide, you stop right there. You don't continue and spend another $200 million in developing the product, another 10 years of company research monies and time, okay? Now, sometimes you'll get a compound that's not metabolized or altered, okay? It's similar to this in a sense, but something like paraquat, I mean, it's not changed. It just goes right in, does the damage, okay? It is not broken down. When the residues, okay, hit the ground, so you've killed the leaves and so forth, hit the ground, the product itself will be adsorbed to soil. And only after a relatively long time is actually the product broken down. So paraquat will hang around. Now, it's not going to do it. It's not soil active, okay? But it'll be attached to soil, and eventually it breaks down, okay? But it is not something that right away goes, does its damage, and then right away it's broken down. So that's what I mean by this. And same with glyphosate. It takes time for these products. Now, the advantage here, of course, is that they're not soil active. Clearly, if they were soil active, there would be issues because they're not broken down. They're remaining in their constituent, in the form that they were applied. They would not have passed EPA. Okay, so these are some of the steps that allow us to have selectivity. Okay, and we'll talk more about that. So, what are the factors that affect selectivity? Why can we apply a herbicide and kill some species but not others? And how does that affect it? Okay. And I'll just name these and go then through each, specifically giving you examples, okay? You can take advantage. You can get selectivity not because the herbicide is degraded by the tolerant species, but you take advantage of plant age and plant height. That's what's going to make the difference. Anybody know what that could be? What could be the plant height? Anybody have an example of where that you've come across where you could take advantage of the age of, say, your crop relative to your weeds or vice versa that allows you to use a herbicide and, knock off the weeds but basically allow the crop to grow? So it's nothing to do with the fact that the crop is able to detoxify or conjugate, okay, the herbicide. Emily, did you have a... The weeds haven't, and how would you actually do that? So I think that's great. That's usually one of the ways. You take advantage of the fact that the crop's already, let's say you transplant. Crop's already this big, but you just now have the, let's say you had clean, stale seed bed, and you now go in, and soon the seedlings are, the weeds are going to start emerging. You could take advantage of the crop being, taller and larger. How could you spray without, because remember, the herbicide might affect the crop too. What could you use? There's a couple of things that we talked about that you could use that could be helpful. Steve? Banding spray. A banding, but what else can you do? There's a certain type sprayer that you could use safeners, but what about I'm thinking in terms of nozzles and
low-profile spray that would below the plant cap.
Right, drop nozzles. You drop below the lower leaves, and I'll show you that. So we can take advantage of that. We take advantage of, and we'll say more about this, but I'll take you through this. Plant height, okay? Anybody? So this is plant age and stage. I was jumping to plant height as well. We just talked a bit about plant height that you could take advantage. How many of you know what happens when you have, say, in a corn or soybean field, a few weeds have gotten, were not controlled. And so you have a velvet leaf sticking out, being 7 feet tall in a soybean crop. Do you know what some things you could do? I mean, it's not just one plant, but you can't spray the whole thing again. Do you know of a technique that some folks might use to be able to take advantage of the height of the plant? I.e., the crop is 5 feet, you've got a nice canopy of soybeans, but then you've got, pigweed or lamb squirters or velvet leaf, which, remember, these are plastic. These species can overtop. Okay, so how can you take advantage? Is there something you could do to take advantage of the height difference? Because if you go in and spray Roundup again, you might actually injure the crop because now the crop has a lot of foliage, and you've already sprayed once perhaps or twice, and plus it's not cost effective, environmentally not the best way to do it.
Is there a way to spray vertically or horizontally?
Okay, well, we'll talk about something called, anybody hear of the rope wick or sponge wick application, where you basically will take care of the height difference and you just brush the plant with something like, the weed I should say, with something like Roundup, glyphosate. But just brush it so that you don't spray the whole area, and you would go through your row And all of these were basically almost like you're going and brushing in. Remember, these typically are systemic herbicides, and I'll show you that. So rope wick methods to try to control weeds that have escaped, and we'll talk a bit about that. Yes? It's generally the same, but sponge wick is basically a sponge, like you would be clean, that's soaked with the herbicide. You don't want it dripping or anything, but as soon as you move it on your row, and I'll show you, I have some pictures, and it'll just, basically brush the plant and go on. Whereas rope wick, it's literally a rope, like a candle wick that's been impregnated or that's been soaked in glyphosate. And the glyphosate is moving through. But it's not dripping because obviously you don't want it to get on the crop. Okay? Now, in some cases, we'll get selectivity because of differential retention of the herbicide on the plants, i.e. the crop does not hold on to the herbicide as well as, the susceptible species of weeds. And so I'll talk a little bit about how important is that in the selection process. How important are these? Okay? Penetration, same thing. Okay? In some cases, we have selectivity because of differential penetration of the herbicide. Okay? Not just retention on the surface, but the ability to get in past the cuticle. And some species, again, related to cuticle and so forth, can do it more than others, and we try to take advantage of that. So that's another way that selectivity, we can use it to our advantage here. Okay? Some herbicides are more easily translocated by certain weed species than others, or certain plant species. Okay? And again, I'll cover these in a little more detail. Just want to take you through the big picture. Okay? The reason 2,4-D, MCPA, dicamba is able to affect the broadleaf weeds is that from a number of reasons, the grasses just don't translocate it as fast. Okay? They just don't translocate it as easily, and thus they're not as affected. But again, if the dose is increased, then you're going to get an effect. Okay? So, and I'll say more about this. This is the main reason that we have selectivity. Okay? These are important. I can give you examples. But by far, the main reason we have selectivity we can use certain herbicides in our crops that will kill susceptible weed species is that our crop is able to metabolize the herbicide. And I'll give you a couple of examples, one being atrazine, which is extremely important. Why we could use atrazine in corn. Okay? And we're going to get things like fall panicum, Panicum dichotomiflorum, giant foxtail being hammered, which are also monocots. What is it? And I'll tell you about the ability of corn, to detoxify atrazine through various steps. Where soybean, we can't use it in soybean because soybean only has one out of the 3 steps to detoxify. Corn has all 3. Take you through that. But by far, this is the main reason we're able to have selectivity. If our crops or favorable species were not able to metabolize, and what I mean by metabolize is basically break down the products to injurious byproducts. And I'll give you some examples. So make sure you keep that in mind down the road in prelim 3 if ever you're asked or you need to elaborate. This is not to say the others are important, but by far the most important. So let's go through each, just giving you some examples. All of that is pretty well in your notes. So I've tried to really match the notes with the presentations. You can take advantage of plant age. How can you do that? Here's an example in general that we're aware of, is that generally corn, and that's an important species here, is tolerant to many post-emergent herbicides, especially before tasseling and after the dough stage, of grain development. It's just physiologically the plant is able to handle it. I'm not saying this is true for all herbicides, post-emergence in corn, but there are a good number of them if you want to get a least susceptible stage, these would be the windows that many of the post-emergent products used in corn, would least impact, even those that could injure corn, This is taking advantage of age, but you have to be aware of that, And the question, of course, that begs is, well, if you wait to this stage to apply your herbicide, is your critical period of weed control gone, that window gone? But you can take advantage of this stage, to gain a little more selectivity for a given product. It's not always used. I can give you the example of Roundup. If you apply Roundup too late, the crop has so much foliage, the corn, that in fact it's even though it's transgenic, corn or soybean, you could still get damage because there's a lot of foliage and Roundup's going to be taken in. And also the plant is not able to break it up as fast. Okay? So there's an advantage. I think Emily was mentioning this, that for soil applied herbicides you can try to control late flushes, okay, in already established crops. Okay? So late weed flushes, if you've got soil applied, you can use drop nozzles. Okay, so your crop is up. Okay, and so now you're getting this weed flush. You can try to use a pre-emergent herbicide. Okay, to take care of any of the seedlings that are coming up, any of the weed seeds. So you're taking advantage of the fact that the crop is older, and it's also a height differential, but it's also older and more mature, and so it could handle it. You don't want to spray the plant. You can ban some of them. It allows you to ban the plant is older, can handle it, just more resistant. Remember, as the plants mature, their cuticle becomes thicker, the roots as well. So they tend to be. You can try to take advantage of this for late emerging weeds by providing these drop nozzles and just getting the emerging. Okay, I mean, if you have a residual herbicide that lasts throughout the growing season, that's fine. But in some cases, we don't have that residuality. Okay, this is an important one. We use a lot in New York. Okay, you can actually, I don't know how many of you actually practiced this, but in alfalfa, we take advantage of the fact that alfalfa is dormant relatively later than some of our perennial weeds. Okay, and when the plant is dormant, okay, late winter, early spring, you can actually go in, and we've actually can use things like paraquat or metribuzin, okay, or even like Bucktrill, bromoxynil, to control, weeds, emerging weeds, but also some established, and paraquat in this case, to basically control the weeds, early emerging, early active weeds, okay? Because alfalfa is dormant, it's not going to take in the product. It's not going to affect it, okay? Even something like paraquat, okay, the plant has to be actively growing to take it, to be able to be effective. If it just lands there, okay, in cold temperatures and the plant is dormant, it's not going to affect it. So this is a nice way to kind of clean a field, but you have to be careful that, you don't push it too long where now you've got the alfalfa, actively growing, because that's going to cause you problems. Yes, Megan?
How do you tell if it's come out of dormancy, even if it's in the infancy of coming out of dormancy?
You typically, it's been, the way it's almost like frost seeding. I mean, it's still almost in this time, in this part of New York State, I would say I've seen it done usually in mid-March, mid to late March. It's been still cold. I mean, and you get the sense. The growers that try this usually have done it before. It's not an easy one that you can just go out and say, oh, but you basically see the plant is still shriveled. It's been you're starting to get this is mainly for things like quackgrass and even things like really early emerging wild oats. The average temperature for wild oat maximum germination is about 60 degrees, 55, 60 degrees Fahrenheit. Okay, so 10 to 12 Celsius, and so even the alfalfa, that's not, usually, a good way to grow. Now, it's not going to be all the weeds. It's going to be those early winter annuals that are kind of already have geared up to come through, especially if you've got a spotty alfalfa where these weeds are coming in, and things like wild radish, wild mustard, you'll see early on. Okay, it's not one that I would recommend, just because if you miss out and by mistake the crop is actively starting to really actively grow, the temperatures have gotten warm enough, but there's no you can't look at the field and say, oh, that you can go ahead and spray. It's just more knowledge about the field and how cold it's been, and whether the plants have started to grow. And that usually we use the weeds as indicators. Quackgrass, 2 or 3 leaf stage already, you start, that's about as far as I would take it. 3 to 4 leaf stage, and after that, if they've gone to 5 or 6 leaf stage, then that's already past. It's clear that alfalfa is going to be coming on strong, okay? But again, what you're doing here, taking advantage, it's age or development. Something's still dormant, you take advantage, almost like using dormant oils before the plants get going, because in some cases it could be injurious to them. Okay? This is the plant height part, okay? And what I want to show you here is basically you're going to try to exploit the difference between the height of the crop and the height of the weeds. Typically speaking, you could take, the weed could be smaller, okay, where you're going to have a directed spray. So here's the crop, okay, and here are the weeds. The weeds are basically shorter than your crop. Then you could use these directed sprays, as we talked about. Drop nozzles that just get those, and yes, the crop can get a bit of the herbicide, but you cannot just spray the entire plant, because the herbicide might cause injury to the crop. Okay? So you get selectivity not because the crop can detoxify the herbicide, but basically you avoid getting the herbicide on it. Okay? It's the same like using shields when you're spraying for the crop. You protect the crop. The selectivity is basically because you provide the shield. Here it's because you put most of the herbicide, okay, away from the crop. You can get a bit of it on it, but otherwise the crop suffers. The opposite is true too. If your weed, as I mentioned, overtops your crop, then this is an example, a handheld sponge wick, okay, that one can use. So basically, think about this as almost like a Mars sponge that you clean your floors with. That's got some Roundup in this case, and you could actually either do it manually. You could just brush, okay, the herbicide onto your target weed, okay, manually if it's not a big field and so forth. And that would basically, make sure it doesn't drip onto the crop that is susceptible. Remember this. These crops would be killed if you'd spray. And at a more commercial level, this is the rope wick. It's hard to tell you, but there's a rope, and there's the herbicide here is glyphosate, and they're not showing it here, but if you could imagine this going through the crop, okay, in some cases, obviously, you can't go if your corn, is 15 feet tall. I mean, that's just, you're not able. But in something like wheat, or I'm not even sure what, even say in turf systems, you could do that. Just brush, okay, any of the standing weeds with this rope wick. And this stuff is not dripping, by the way. It's not dripping. It's really, it's calibrated, and basically you need to brush up against it. And again, so what you're looking here is usually you're using a systemic herbicide, because you're not going to get the perfect coverage. You're going to get just a bit of it on probably one or two top leaves, but then it's going to be translocated down. Okay? Yes?
So you probably have to make it more concentrated solution.
They tend to be a little more concentrated. Yeah, that's exactly it. Okay? But it's used. If you I don't know, how many of you have actually seen it? Have anybody seen this? Matt, how have you used rope wicks or just hand? It didn't work. No, that's just were the weeds just too big, or?
We're trying to get milkweed and sweet corn up maintenance, so it's just taller than sweet corn.
But it didn't work. Now, of course, what were you using? Glyphosate? Okay, because one of the things with milkweed is even a spraying of direct cover that's a tough weed to control. When you've got those creeping roots down 15 feet, 10, 15 feet, it's tough. But okay, it is used. You need to be aware of, but you're going to take advantage of the height difference. Okay, so just be aware of these parts. I've certainly seen the hand ones, in vegetable production, where the fields in some cases are not big, and you're just almost like roguing. You're just going there and brushing, almost like a flame weeding. Okay, so
They use it a lot in natural areas too.
that's right, where you really want to be careful with sensitive or unique species, rare species. You can't go in there and just spray, and so often that's done. I've seen it actually done on invasive shrubs, where you can even take advantage where they have the sponge. You can actually just, in some cases, you can actually apply right to the bark, and you just put the sponge right against the bark, and it's just taken in. That's a good point. I've seen that. We usually also use something called cut stump applications for invasive shrubs and species in natural areas, if some of you are interested, where you basically make a cut, and as you're making the cut, you're also injecting the herbicide right into the cut stump, and that's taken in. And so that's also used. Okay? So this is, again, taking advantage of the height differential. This is directed spray that's aimed towards the base of the plant. That's not to say the plant might not get some of the herbicide on it, but certainly it's not going to receive a large quantity, and it can tolerate that. It can make it pass. Otherwise, there's no way. You could not apply this if you were going to spray over the top of this, okay? Either as banding or a spot spray. It really has to be a directed spray. Yes, Joe?
Where do you see that? Do you see that on a commercial level, especially at the drop thing?
Oh yeah, I've seen it. I've seen it in particularly in vegetable production. I've seen it in tomatoes, where they're going and get there's a second flush coming up, and they go right into rows.
Because I guess the one way that I would really see it, because if you had a big sprayer that's a ton smaller, so if it was GPS guided, and you could drop a nozzle, like put a cabbage plant, do it.
Yep, and that's where some of the technology is, and we think we talked about it in IPM. I think where the technology now where we're at is we actually have cameras that are able to identify and differentiate the crop from the weed. Before it's not just there's a weed, there's something green. Well, now it's just here's the crop, here's the weed based on spectral signatures, and then dropping the nozzles, not just able to say there's weeds here, spray, but actually what weed is here? Oh, it's foxtail, okay, and mixing in the correct herbicide using drop, okay. And this is some of the work that's going on at UC Davis. I mean, you're interested in that, you should, they call it, they're trying to, I think that it's patented. It's very costly, of course, but it's able to identify the weed, hopefully, and you don't want it to go wrong because then it starts spraying stuff on your tomatoes, and that's where I've seen a lot of the work. But that's a good point. Stuff is GPS guided. This wasn't initially done this way, but when I've seen it in vegetable production, it was basically, the grower was there and just sprayed right under. But again, the reason he or she was doing that was because the herbicide, there'd be no selectivity. You would kill your crop. The crop was simply not able to handle that herbicide. But because of the height differential, these things emerged afterwards. You had cleaned, your field. You transplanted. The transplants are already, bigger, but of course you're going to have weeds coming up. Take advantage of that. Unless you're using a residual, something like Treflan that's going to last through the season. But in some cases, in some crops, you can't do that. Okay, just want to show you, and I know it's not that clear, but hopefully in your notes it might be clear. What I want to show you is how you can take advantage of the physiological differences between where the active growing point is in a grass, okay? And it's called the Calliope Taylor node, okay? And it's really hard. And I just, basically the apical meristem. And so what we have here is, we have wheat and wild oats, okay, is an example. A Venus species, but it could be definitely, in this case, wild oats, okay? Look at where the Calliope Taylor node is, which is the active area where the herbicides would be taken in, okay? It's right down here. For the wild oats, it's right up here. If this is your herbicide layer, let's say you're doing a pre-emergent, and in pre-emergence, the herbicide, if you need water to activate, it can actually percolate down, 2, 3 inches, 4 inches down, okay? Or even if this is, PPI, let's say to 4-inch depth, the fact that the active zone that picks up the herbicide for the oats, or at least in this case the wild oats, is right in the herbicide layer, treated area, it is going to be taking this product, okay, constantly. It's going to be basically killed because it's right in contact for a long time. Versus wheat, okay, that the active growing point is below the treated area. And yes, sure, it needs to, you got the hypocaudal, i.e. the stem needs to grow through, okay, the herbicide-treated area, but it's not an actively growing part of the plant. I mean, it's going to go through. They're fairly tolerant, okay? And so you take advantage of this difference in where the active growing point is in these two grasses, into two monocots, okay? Otherwise, if this area was treated with herbicide all the way down to this area, you would have serious damage. Do you remember for pendimethalin, prowl, one of the things you've got to do, and it's on the label, you've got to plant corn at least 2 inches deep. Otherwise, it's going to be affected. And that's basically trying to put it out of the treated area. for pendimethalin, okay? Because some products that you're just not, there isn't the selectivity there, but if you, the amount of time that the crop or the favorable species is spending in contact with the herbicide, is reduced, it's got enough to be able to make it through. If it's soaking in there like this, it's done. That was the same with the rutabaga issue that I've talked to you about, where basically there was hilling going on, metallochlor was put in, okay, and you had the transplant. Basically the plant was soaking, the rutabaga was soaking in the metallochlor. That was not supposed to happen, okay. You were supposed to have the metallochlor. Yes, the parsnip as it grew, or the rutabaga, was going to go through the herbicide layer, no question. It was going to make it through, but it wasn't going to be spending 2 weeks, 3 weeks soaking in there, okay. So this is an example where you could take advantage of physiological or morphological differences. Yes, Bob?
Is this node the precursor of the crown?
Yeah, and it's basically where you will, and it eventually does move up. It'll move up to closer to the soil surface. But initially, if the planting is done correctly, okay, there is this difference. It's just a morphological difference that folks have noticed. And they were wondering, why would this herbicide not get to wheat? Number of examples, okay? And this is, trifluoril and treflan is a good example of why you could use it, okay? Because that's where, at least for soil-applied herbicides, that's where it makes it in.
So the distinction is also drawn there that I guess the parenchyma tissue of this new capable area is able to absorb.
Right. And it's really, that's the active area for something that's been incorporated. Think of this as being 4-inch depth, okay, mixed in. This is a pre-plant incorporated herbicide, so it's mixed in. And if the wheat is seeded deep enough, because of that, it's out of that critical zone. Now you will say, well, what about? Certainly wild oats they're not all going to be here. But if you think about it, most of our wheat seeds are within the top 2 inches. Certainly you're going to have some wild oats and species in here, and here, of course, it wouldn't be as affected. But it also is likely not to emerge if the seeds are relatively small. They're not going to emerge if they're below 5 inches or 6 inches. So, but it's just to give you. you could, in some cases, you could take advantage of that. And the perfect example that we use is for corn, pendimethalin. You plant corn 1 inch depth, 1.5 inches. Your planter, your seeder is not, calibrated properly. You're going to have damage. And we used to see it. I remember one time Kathy, by mistake, didn't plant. We always would try. Oh, let's plant them at 1 inch. Corn was gone. We're supposed to, this is a registered product, but you will read it. So that's where the label comes in, okay? So you need to take advantage of that. This is just showing you could also take advantage of root depth. So it's not just, above ground, a bit similar to what we have. Selectivity based on difference in root size or structure, okay? If you've got a herbicide, you've got a plant that the root, system is very close to the surface, soil surface, and the leaves are right there, you're likely, these guys here, 2 and 4, are likely to be more easily killed by a spray. The root system is not as, particularly if the herbicide doesn't travel very far. Roundup, whether it hits this, that's got a root, this is why you use something like Roundup. It's going to go after Canada thistle no matter how deep the roots are. It's going to take some time. But for some herbicides that are not translocated very far, some of our diphenyl ethers, okay, aciflorifin blazer, okay, is a good example. They don't go very far. Then you would imagine that if they don't have to travel as far, they're likely to knock off a plant that's got a shorter roots or the plant is younger. And this is where you have to be careful sometimes when you're working in orchards and you've got dwarf trees. Then in some cases they have their root systems right close to the soil surface. Sometimes we see damage. They're not only prone to drought if they're not irrigated or weed pressure, but sometimes also from herbicides or pesticides because they're right at the surface. They're not as protected. Okay, so again, some of it is more theory than actual practice. Now we've got such good selectivity with herbicides, but I think you should still be aware of that. You can take advantage of the retention ability of a plant. You've got example. You've got something like onions. vertical growth of the plants, very waxy. You spray a herbicide, boom, bounces right off. Whereas your susceptible weeds, if they've got these horizontal leaves, like, you know, velvet leaf, they're just sitting out there, the herbicide is going to be retained. Much easier. That's why for weeds that are, i.e., have the same kind of morphology, you know, waxy and, you know, and also vertical type growth, you can think of something like, you know, narrow leaf plantain or something, although it's, you know, the leaves are not that waxy, that they would be more difficult to control, and hence we would have to use wetting agent stickers, okay, just to allow the herbicide to be there. But you could take advantage of differences in retention to basically knock off broadleaf weeds with horizontal type leaf architecture in, say, something like a monocot or even something like onions. Okay? Do you see? I mean, that's something you could kind of think about. Where I've actually seen this sometimes used is, it's not often used now, but we used to have granular forms of herbicides, and in vegetables you would use this a lot. And what you would do is you think about when you're fertilizing your lawn with the little granules, the herbicide in these in these horizontal leaves would basically be caught in the axils, okay, and sit there and on the leaves. It just, you know, especially if you have stickers, and they would just wipe the plants out, okay. Whereas very often for your monocot, if you were in carrots, the leaves were so finely dissected that the granule would just fall right to the ground, where it wouldn't, and so it wouldn't impact. Very little of it would actually go on the crop. Otherwise, the crop would be killed. So you're taking advantage of the architecture, you know, and the retention ability. Okay? So again, that's something you need to think about. If you're spraying and, you know, stuff is falling off your weeds, you know, because of their architecture, that's not good. That's not what you're looking for. Okay? In terms of differential penetration, again, you notice these, you know, yes, they're examples, but they're relatively minor to metabolism, which I'll, you know, we'll talk a little more about. But in terms of penetration, okay, as I just mentioned, differential age, the older the plant, the more mature, the greater, the thicker the cuticle. If you're under drought conditions, the thicker the cuticle, okay? So, you know, it's really tough when you're trying to spray a herbicide and you've had a week of drought. You know, the cuticles on the weeds are you know, your weed species are very thick. There's going to be trouble penetrating that cuticle, okay? Or if you have trichomes or hairiness, you know, that, you know, the droplet, instead of being flat on the leaf surface, is now being, you know, beads up on top of some trichome or hairs or fuzzy plants. You see that. That is not really good, okay? And so the key here is you might want to take advantage of you know, can you take advantage of differential penetration by focusing in on the cuticle or seedlings relative to mature plants, okay? So seedlings are so much easier to control. That's why pre-emergent herbicides, PPIs, work. I mean, growers don't want to use them because it's extra steps, and particularly PPIs, but in terms of where's the crop and the weed most susceptible, that's it. That's the stage. Don't wait till the plant's this tall and it's got these thick leaves, large, you know, well-developed cuticle. That's usually not a good thing. However, as I mentioned, there are relatively few examples of differential penetration as being a major selective force, you know, being the main reason why we have selectivity, okay, especially if the plants are the same age. You know, the crop is the same age as a competitor weed or same species. Why the difference? Usually that's not the main reason. The ability to penetrate, that's not, okay? If there's a difference in age, then a whole, you know, related to cuticle thickness, that's another ballgame. And so that's why we use wetting agents, okay? We try to control, to alter the herbicide formulation to decrease the retention-related penetration. In a sense, if there is a difference, you know, we're going to get by. We're going to try to remove that difference just because it's not an important factor. What's more important to us is that the herbicide makes it into the weed. So even if there's a difference in selectivity between the crop and the weed, usually that's not that important. So we almost forget about it and put in a wetting agent or a sticker, and we try to reduce this retention, any differences that might exist, just because once it gets into the plant, okay? And so, you know, you might increase selectivity, But you have to be really careful now if you're going to add wetting agents and so forth to really use the right amount, the right dose. Because now you're facilitating the herbicide getting in. Okay? And if you use a higher dose than you're supposed to, this thing is getting in. It's not going to sit on the soil surface or on the leaf surface. Okay? So, yes?
If a herbicide is got high water solubility, will the label tell us or recommend using wetting agents to increase its penetration?
Absolutely.
Something that you can just look at the solubility and say, I'm going to get this in.
No, they clearly stated they'll tell you if it's best used with a crop oil concentrate to increase the uptake of the herbicide. So yeah, very often it'll tell you specifically, or that they've already mixed in the formulation of wetting agent because of solubility issues. So yeah, it's not something you have to really be. So yeah, just recognize that they're gonna tell you, and that's why they say be very careful. We've got a wetting agent and so forth. Be careful about how you're going to lose that selectivity if too much of the herbicide gets into the crop as well. You want it to get into the weed, but the crop, you're using a crop oil concentrate. It's also allowing the herbicide to get into the crop. You don't want the crop to be killed, but using the right doses, that typically makes it. Okay, and I'll just finish with this slide since I've seen Stephanie is going to be here. Translocation. So could it be that we have selectivity differences because certain herbicides are translocated more easily in the plant, i.e. they make it in, but for whatever reason, broadleaf weeds really move something like 2,4-D, MCPA, Banvel faster to the site of action where basically the herbicide kills an important or stops an important physiological process? Yeah, that's probably, in some cases this is true. Okay? As I mentioned, some herbicides may be, even when they get in, they may be conjugated, absorbed, or compartmentalized. In a sense, the fact that you could use linuron in carrots is that the herbicide is differentially translocated relative to susceptible weeds. Susceptible weeds don't bind it to another product and then move it into the vacuole for safe storage kind of thing and breaking it down. It goes right to where it's supposed to do the damage in photosystem, in the photosynthetic pathway. Whereas, linuron in some, in the case of carrots, they conjugate it and they basically don't allow it to move. So it is a form of translocation. It basically stops it right at the entry point. Get in, but then it makes it through the cuticle, but then it's not going to go to the site of action. It's not going through the xylem. It's not going to go through the foam. It's going to stay as far away from where it's going to do damage as possible. Okay? Here are some examples of, what are some examples of crops or species that do this? Norflurazon is in glands, in glanded cotton. Some of the, the varieties, cultivars have these glands. And this herbicide is actually commonly used down south. The reason you could use it in cotton is that it's compartmentalized. It's put away in the vacuole so it doesn't do damage, then eventually broken down. And in some cases, it could take days, weeks. But it doesn't affect the plant, okay? You've got to be careful not to overdo it, overspray, okay? Linuron in carrots is bound or inactivated at the point of entry, okay? So that's differential translocation. It's not that the herbicide is, that the carrots are breaking it down right away, like you'll see with atrazine. No, they take it, they conjugate it, they don't make it move, okay? So that's 2,4-D and other phenoxy are translocated at a slower rate in grasses. We don't know why, but they are. And that's why you could do it. That's why ChemLawn can be using these phenoxies to control dandelion and plantains in your turf, okay? Compared to the broadleaf, just take it in. Just take it in. No, not a problem, okay? But these are the exceptions rather than rules. And what I'll be talking about next class, when you guys get back from Thanksgiving, is that most of the product, the herbicides, are moved to the site of action. The main reason that we have selectivity is that basically they are metabolized. They're broken down, detoxified by the crops, in this case. Okay? We don't want the weeds to detoxify. And I'll show you the examples that the total opposite occurs. Some weeds will take something that's non-herbicidal, like 2,4-DB, butirac, convert it to 2,4-D, which kills them. And you wonder, where is the selective pressure there. Why are they doing that? I mean, they could have just, if they just, and wheat doesn't do that. Wheat, you can use that, you can use, some of these herbicides, or I should say alfalfa doesn't do that, or lupins don't do it, okay? So, I will stop at that.